Hey there, C# friends. My name's Matthew. I'm the C# artisan, and today I want to talk about async await. Now, async await is a super common pattern in C#, and I'm sure all of you have written some async await code. But I want to make a confession. It wasn't until very recently that I think I actually understood what's really going on with async await. I had a feel for it, but I didn't have a really clear mental model. So today I want to kind of take you through my discovery process where I dug into it, and I think now I really do understand what it's doing under the hood. So let's just begin by looking a little code where we demonstrate async await and watch it in action. So here we are in Visual Studio, and I've set up a little test project for us. Let's just give it a quick read through. So I'm declaring a static integer, duration, my usual startup where you press enter to begin, and then this really interesting line of code where we are running a function called run test async and passing in duration. Now, in this first video in the series, I'm not going to go into all this jazz. We'll talk about that in part 2 and what's happening here. The important thing is here in run test async. So as you'll see, it's marked as async and returns a task. And inside the body of this, we have 2 await statements. So it logs the fact that it's starting. It logs the fact that it's going to do something awaitable once, and then it calls it. And then it's going to say that it's going to do it again, and it calls it, and then it logs that it ends. And when we're all done, we should get a little log message that says done. So what is this do something awaitable? Well, I've created an Azure function and published it to Azure. And it has an HTTP endpoint that I can call. And this Azure function, it is meant to just delay. When you call it, you pass in a parameter called delay seconds. And it will wait for that and then return. So this allows us to do something truly awaitable. So this is pretty simple. We log the fact that we're beginning it, and I format our function, putting in my key and the duration, and then we simply call client get async, and we await that. So this is something awaitable. All right, that's the program. Let's run it. We'll start it. I'm going to press enter to begin. And now it's doing something awaitable, passing in 4 seconds. And then it's doing something awaitable again, passing in 4 seconds. And then it's done. So the thing I want to point out for starters is that our first do something awaitable call happened at 52 minutes and 43 seconds. And it took about, a little more than 4 seconds. It came back at 52:48, at which point our second call started. And that also took 4 seconds. So the key here is these things ran one after another. They didn't run in parallel. We didn't get our 2 awaiters happening at the same time. And when you look at the code, what you can see is that this line here, await, do something awaitable, well, it's blocking while the awaitable thing is happening. Just to really hammer that home, I'm going to set a breakpoint here on line 29, which is after this one completes. And let's just run it again. And we'll press enter to start, and it's doing something awaitable on line 27. And our breakpoint on line 29 doesn't hit until the awaitable thing completes. So I want to admit this kind of drove me crazy. This is really the part where I was like, wait a second. I thought the whole point of async programming was that you could do more than one thing at a time. But this is just blocking. Like, to me, this just looks synchronous. My code here has to wait on this code. The function can't complete. So it's a little bit like, imagine you walked into your favorite coffee shop and you ordered a coffee. Now, we normally expect the process of getting the coffee made to be asynchronous, which means you can go sit down at a table, pull out your phone, doom scroll the internet a little bit, watch TikTok at least for the next, 24 hours. And then when your coffee's done, you go pick it up. But this is like I ordered my coffee and then I'm frozen. I can't pull out my phone. I can't go sit down. I'm just blocking, frozen, waiting for my coffee to appear. So this is where I kind of got hung up and I was like, I really don't understand what's happening here and I don't understand the point. So there is a point. This is doing something important. And now I'm going to switch over to a little PowerPoint presentation where I can explain what is really going on here and why it matters. So when we're working with async functions, they run on thread pool threads. Really behind the scenes, a task is being created. And as you may know, tasks get assigned thread pool threads. Now, if you want to take a deeper dive into the thread pool, go ahead and watch video 10 in my series on threads. And I go into a little more depth on the thread pool. But for today, all you need to know is that our async code needs a thread pool thread. And here we have a very sad little thread pool. Our thread pool has exactly 3 threads in it. So let's imagine now that we are beginning async function 1. Right? Our code wants to run this async function. So in order for async function 1 to run, we need to be assigned a thread. So we've got T1 out of the thread pool, and now our function can start running. Step 1 runs, step 2 runs, and then we get to step 3, which is our awaitable step. Now, let's imagine that step 3 is going to take a while, maybe. Right? It's a long-running thing, and that's why we are awaiting it. So this code blocks, as we talked about. Now, while we're waiting for step 3 to complete, let's say we have 2 more functions we want to run. We decide we need 2 more copies of the same one, or maybe they're different functions. Doesn't really matter. So async function 2 and async function 3 each get a thread out of our thread pool, and they both begin. So now all 3 of our functions are working away. And as you'll see, we now have no more available threads in the thread pool. So you can probably guess what's going to happen next. We need to start async function 4, and we can't because there's not an available thread in the thread pool. We are now experiencing thread starvation. So this is where async await is going to come into play. And let's rewind a little. Let's back up the story a bit. So here we are. We've got threads T1, T2, and T3 allocated, and our 3 functions are running. And step 3 is awaiting right here. So when we await that call, what really happens is the .NET framework creates what's called a continuation. So a continuation, you can think of it like a bookmark. It says, okay, function 1 got to step 3 and it began it. And we don't know exactly when it's going to be done. So I'm just going to put a bookmark there and say, hey, that's where we're going to resume when we can. It's going to start listening for a signal that it's okay to restart it. And while it's waiting, thread 1 goes back to the thread pool. So function 1 is in this interesting state. It's kind of suspended, right? It's waiting for the result of step 3. It's got this continuation set, but it is no longer using the thread pool thread that it was using before. Now, when we need to start async function 4, we're in business because we can assign it thread 1. So async function 4 gets thread 1 and it gets started. Now, just to complete the story, let's say that async function 2 has moved to step 3, which is awaitable. So the operating system creates the continuation, or the runtime creates the continuation, and that allows thread 2 to return to the pool. Now, in the meantime, function 1, step 3, completed. We got the special signal that says, hey, we're done. Maybe it was a HTTP async get that came back with our result, whatever the result was. So the continuation is like, oh, great. Now function 1 gets to continue. So it summons a thread pool thread, and it says, async function 1, you're good to go. It moves on to step 4, and our continuation is resolved. So that's what async await does. It doesn't let you run multiple parallel code inside your function. There's a way to do that, and we're going to talk about that a little bit. What it does is it allows for more efficient thread pool thread sharing, and it avoids the problem of thread contention or thread starvation in your thread pool. So for a tiny little app, this probably doesn't make much of a difference, but let's say the code you're writing is ASP.NET controller code, and you don't know how many requests are coming into your web server. Could be 10, could be 10,000. And you may have one piece of hardware underneath it, or you might have a bunch of blade servers running in Kubernetes. We don't know. There are going to be limitations on the thread pool, and writing that code as async allows the operating system and the .NET framework to efficiently assign your work threads and not have contention and thread starvation. So that's what async await is for. That's the problem it solves. Now in part 2 of this video, I'm going to go back and we're going to talk about a few things that I've already mentioned. We're going to talk about how you really do run multiple things simultaneously if you really want to. We're going to talk about that interesting bit of code in my main function where I created an awaiter and did all that jazz. And we're going to talk about what it really means for something to be awaitable. In other words, what is that weird signal that the continuation is using? But for now, at least, I hope you've got, finally, a clear mental model about what async await does. I know it took me a while to get there, so hopefully this was helpful to you. Hey there, C# friends. Are you enjoying these videos and finding them helpful? I hope so. And if you are, please go ahead and like the video on YouTube. If you haven't already, please subscribe to my channel and feel free to leave a comment. I would love to hear from you.